All right, so hi everyone. So this is the SIG-Cloud-Provider intro plus deep dive. Let's start with introductions. I'm Andrew Sai Kim. I work at VMware. I'm one of the co-chairs of the SIG.
And I'm Jago Macleod. I'm a director of engineering of Kubernetes and GKE at Google.
And I'm Chris Hoge, and I am a strategic program manager at the OpenStack Foundation.
Okay, cool. So I guess we'll start by giving an intro of the SIG. But for the most part, we allocated about 80 minutes for this. And we're going to keep it very informal, keep it discussion-based, try to get feedback from the community on what we can do better in this SIG and what are some of the future enhancements that we want to make for the cloud provider integrations to make Kubernetes better on various platforms that Kubernetes runs on. So I'll give like a really quick 5-minute intro to the SIG in case there's some new people here, and then we're just going to go straight into a discussion-based kind of talk. So I'll stand up for this part. All right, so yeah, like I said, agenda. So SIG intro, going to talk about our charter, areas of focus, sub-projects, and then we have a few items lined up for the discussion, but we're going to try to also get a poll from people to see if there are any other like new topics that we want to discuss. If you want to know what a SIG does or what areas of focus or what their scope is, always go to their charter. There's always a charter file in the community repo. And so for our SIG, the scope of our charter is, or the mission is, to simplify, develop, maintain cloud provider integrations as extensions or add-ons to Kubernetes clusters. So if you're running Kubernetes on Google or on Amazon or on vSphere, OpenStack, we're trying to build out the integration points between Kubernetes and the cloud provider so that the integration is optimal, and but also that Kubernetes isn't being built with only a few platforms in mind, but that it's kind of accounting for all the various platforms that it can run on. And so areas of focus are extension points between Kubernetes and a cloud provider, all the APIs and interfaces to provision and delete resources that are associated with the cluster, how to configure a cluster to actually enable that integration, and testing frameworks against Kubernetes and the providers. And so these are, I'm not going to go over all of them, but these are some of the things that we own, interfaces, Cloud Controller Manager, some of the EDE tests. Important one is all the sub-projects that were owned by some of the previous provider-specific SIGs. We have an effort to kind of fold the governance structure so that we have all the providers under a single SIG, so we'll talk more about that later. And then we also do some cross-cutting work with SIG testing and SIG release to make sure that we're bundling all the cloud provider integrations together in the releases in the right way. We're working with SIG docs to write better documentation on how to enable that cloud provider integration and all the features that it comes with and all that stuff. So yeah, if you want to check out what sub-projects we own, again, go to the community repo under SIG Cloud Provider, and in the README there, we kind of list out all the code bases that our SIG owns. So if you want to make changes to any of these repositories, come join our SIG meeting, and we can chat about all that stuff. And so yeah, let's go jump straight into some questions.
Sure. Thanks, Andrew. I can do the arrow here too. Okay, so what we did in Seattle that seemed like it was pretty successful, and we're going to do again here, is make this more about a discussion. I know it's siesta time, but we're going to ask you to sit up and participate a little bit and wake up. And so what we're going to do is spin through a description of a few pre-planted discussion topics, and then open for any suggestions of discussion topics that are about the same level of granularity. We're going to vote on order, and we're going to kind of time box, but work through an order of the votes we receive. It's going to be not really scientific, but it'll be close enough. And some rules for engagement. One, be respectful. Please wait till you have a mic to discuss. It's not just the people in this room, but it's also folks who may watch a recording later. So it's really important to have the mic. Please introduce yourself and maybe what you work on or what your interests are the first time you speak. You don't have to do it every time, but that's also helpful. And the goal here is to get various perspectives on an idea, not to just trade the mic back and forth between two people. So we as moderators may ask you to give someone else an opportunity to speak. And yeah, we talked about the talking stick, literally. Raise a hand, and one of us will get you a mic. Okay, so first up, the initial, the starting point of this SIG was a working group specifically for the cloud provider extraction. The initial set of 7 cloud providers existed in Kubernetes. That's what we mean by in tree. And then it became clear as there were potentially dozens, now there are something like 80 providers of Kubernetes that are certified conformant Kubernetes distributions or platforms. We didn't want 80 SIGs, and so it became clear that we needed a different way to organize the code and not compile into Kubernetes itself every cloud provider implementation. So this is an ongoing effort of this SIG and is one of the primary focus areas, this is one of the topics. So one question that's come up a lot is what is the timeline, not just for full support of out-of-tree cloud providers, but also for the actual removal of all the code. This is hundreds of thousands of lines of code on the order of 50 or 100 meg. Like there's a massive binary size decrease if we can pull this off. So our security teams are happier, our customers pay for less resources. It's good all around, but it requires a lot of coordination across many companies and corporate boundaries. And those of us who have in-tree cloud providers have a very complicated set of steps to migrate the existing install base and make sure we can roll back and all of these things. So this is one. And we have a proposed timeline for that. Another is the SIG governance. And we talked a little bit about folding the existing cloud provider SIGs. We have a SIG GCP. We're folding that under the cloud provider as a sub-project of SIG Cloud-Provider. One of the issues that existing SIGs had was time at these events and some of the infrastructure around Slack channels and ways that their users can find them for support. And so user groups are a replacement for this concept that we think is the right way to go. But this discussion would be about what are some of the benefits that folks still have concerns about, or how should we model that? And what are the weekly meeting structures? Is there value in being consistent on that so that end users can find the right place to ask their questions and fan that out? We just talked about user groups. These still need some more definition. This is an idea, but not a really fully fleshed out concept yet. We need some concrete requests to ask of the CNCF to make sure that providers have the right infrastructure to provide value to their end users. And we need some level of expectations or criteria for a cloud provider to get that infrastructure. There's a cost to us as a community for maintaining that. If you have 2 users, maybe you don't need a weekly meeting and a Slack channel and a this and a that. But it's still useful to be able to discover at the same level. And one of the concrete questions, like how long do we think we need for a user group session in San Diego, which is KubeCon at the end of this year? And then I think the last of the example or preceded topics was the code organization for cloud provider subprojects. And this one gets tricky really in the hierarchy of this. So SIG AWS itself has subprojects, so there's sort of subprojects of subprojects, and at what level of granularity do we need owner files to let those projects proceed at the cadence they want, with the velocity they want, but still have some level of sanity and not too much process. It's a little loud. The ownership is one topic, and then the discoverability. We want to make sure that as we break down into more and smaller sub-projects, we don't make it impossible to find what you're looking for, so some level of expectation around how to find those things. Oh, one more, enhancements. Yes, so we have had many requests. This has a risk of becoming the junk in the trunk SIG, where everything ends up if it doesn't have a home. That may be a reasonable outcome, but we want to make sure we do that intentionally and not just by accident. And so some of this is circles around conversations that have broadly overlapping concerns with other SIGs. And so provider-specific topology labels you maybe see on Kubernetes dev mailing list, topology-aware scheduling, and whether a rack or a machine is something that we want to add to region and zone. Everyone has an opinion. We just need to figure out how to order the process so we can come to decisions that are reasonable given where we are now. Credential providers, they're kind of similar IAM concepts in multiple providers. It's really hard to come up with the right level of abstraction that isn't just the minimum, kind of bare minimum. So those require deep thought and real proposals and compromise. So rate limiting libraries and utilities for cloud APIs. APIs, I won't read them all, but these are really, the general bucket here is how to draw the lines of scope so that we can make progress and not just have conversations, but actually make progress. And what we want to do here is figure out what are the highest priority topics to consider and make progress on in the next several releases. Rather than getting 20% of the way everywhere, let's get 100% of the way somewhere.
Yeah, and this isn't the fixed list. Like, if you wanted to propose an enhancement, like now would be a great time, and we can add that to list and prioritize that for 116 or 117.
Yeah. Okay. So you got a sampling of 5 pre-seeded discussion topics. Does anyone else here come with a specific topic in the back? Maybe Andrew's on his way. That's about that level of granularity that we could do instead of those things. We just came up with some ideas, but you may have better ideas.
Hi, my name is Doug Hellman. I work at Red Hat. I'm working on a bare metal provisioning tool for Kubernetes. And I'm trying to figure out, so I've been engaging with the Cluster API group, and I'm interested in figuring out, like, if we brought something upstream, would it live in that group? Would it live in this group? You know, do we have cloud provider, not a cloud, or is it some other thing, or is the group scope too limited? You know, I don't know whether that fits into the governance question or the
No, it's a really good question.
Or, yeah.
We did actually, just briefly, I'll say, we struggled with the name of the cloud provider SIG initially, whether it was just provider, that seemed a little too vague for exactly this reason. But I think there are qualities that either public, private, or otherwise type of flexible environments may provide, and it's a totally reasonable topic. So thank you for that one.
Yeah, and I actually have an answer to the specific question based off of the contributor meetup over the last week. So if you think of SIG-Cloud-Provider as, at a high level, it's an advocacy group for all of the providers. And so we all have common interests and common goals. And SIG-Cloud-Provider is a way to express those to the larger Kubernetes community and advocate for those. And so one of those is how do we manage and organize code repositories? So if you are a cloud provider and you have cloud provider code, then we will help you set that up inside of the Kubernetes organization and help you get testing and report that back. Now for the other SIGs within Kubernetes, like Cluster Lifecycle and also in storage, they also have providers who are providing implementations of the APIs that they're giving. One of the services that we are offering is to help set up and manage those code repositories. And so with storage, they would like us to do that. In our conversations with Cluster Lifecycle on Monday, for the time being, while they're still figuring out how they want the projects to work and how they want them to be organized, they are going to take on that responsibility, but there may be a point in the future where they don't want to do that anymore, and that will move our direction. But for the time being, Cluster Lifecycle in particular is going to manage all of the provider repositories.
For Cluster API specifically.
For Cluster API specifically, yeah.
So let's hold off on more discussion on that one, but it is a candidate as a topic for discussion as of now. Are there any others about that level of granularity? Anyone come in here thinking, my goodness, there's only one question I wanted answered and none of these things have anything to do with it? No. Okay, so we will spin through in order and add the provider, not a provider question to the end as an equal voting opportunity. You can vote for multiple options if you would like to. That's totally fine. And Chris will keep count for those votes. So first one is the cloud provider extraction migration. How many have an interest in that area and want to learn more? Want to talk more? Okay. Order of magnitude is totally reasonable. Okay. The SIG governance. How do we structure all of these moving parts and try to anticipate where they'll go? Yeah, see, no one wants to talk about governance. Even people involved in governance don't want to talk about governance a lot. This is where it becomes very clear that it's a public servant role, not a role of power. We'll move on. User groups. Who wants to know more about or ask for specific value that they currently have out of a SIG that they want to make sure that is maintained in user groups? All right. And code organization for the cloud provider sub-projects or not cloud provider sub-projects in some cases. Okay. And then enhancements. And they may be these enhancements, they may be others, but really it's about how do we pick what to enhance and how do we work together on it. Okay. And then the cloud provider, not a cloud provider. What is the scope of a cloud provider? How do we determine what's in or out of scope of that? Okay. Got it? Okay. So, Chris, what order would we like to go in?
So we're going to start with the extraction. I think that was the #1 topic. The 2 governance issues, I think, go to the bottom of the list. And then we have enhancements, I think.
Enhancements and code organization.
And also provider, not a provider, probably are the next 2, 3, and 4. So I think that's a good order for that.
Okay. I heard that extraction is first. I don't know what comes next, but Chris will help us transition to our next topic. We will take, call it 15 minutes for this one, just based on feedback, and we'll talk about this. And if your topic was not selected, one of us would be happy, or all of us will be happy to follow up with you afterward and make sure it makes it into the SIG agenda for a follow-up SIG meeting. I should have said that first.
So I can give a quick summary of
go for it.
This one. So if you've ever stood up a cluster on Amazon, Azure, or GCP, whatever, you'll know that like all the components have this -- cloud provider flag, and if you enable it, it does things like set the proper node addresses on your nodes, set the right topology labels, and all that stuff. And so this effort is to try to remove like all of the cloud provider code that's embedded in all those components and move it and migrate it to a new out-of-tree component that is customizable, extendable. Anyone can build their own, deploy it on their cluster. You can tweak the implementation per provider. You can release it at your own cadence. It's kind of following the whole like CNI, CSI model where like you can deploy your own version of a provider implementation yourself out of tree. And that also means that from a security standpoint, from a build and release standpoint, all the core Kubernetes components don't have this like hard-coded embedded logic on a provider basis. So that's kind of the goal. The trickiest part here is the millions of clusters or nodes, whatever, that are already in tree. Like how do we safely get those clusters migrated to this new model? And it's kind of, again, a similar problem with like CSI where it's a matter of adoption. Like how do we get early adopters to use it, test it, vet it out, make sure that it works in the way it does, make sure the functionality is exactly the same, and all that stuff. So this effort is mainly around that. Anyone have questions about that so far?
Is anyone actually running an external cloud provider in production, Andrew?
Yeah.
Oh my goodness. Yeah.
Do you want to give a quick summary on like what DigitalOcean is doing with the out-of-tree provider?
So yeah, hi, my name is Timo. I work for DigitalOcean, and I'm basically your successor. You used to work for DigitalOcean, and I'm now the maintainer for the CCM component for DigitalOcean, and yeah, we're using it in production for quite a few months, and yeah, that's like the rough overview.
Yeah, big props to Dio for owning that. So yeah, they're probably the biggest production deployment of managed Kubernetes offerings that are using the Cloud Controller Manager out of tree. So one of the luxuries that they get is like, oh, there's a bug in the provider integration. They can deploy new image of that component and throw it at clusters without having to wait for the next Kubernetes patch release. Or if it's a new feature, they don't have to wait for the next Kubernetes major or minor release and so forth. So that's pretty cool. Do you feel like there's any limitations with like the current out of tree architecture, the way things are set up? Like, do you want to add anything that would make it easier to deploy out of tree clusters, or do you think it's like good the way it is?
I'm not sure if I have anything in this regard. I think that's okay. That's been working for us fine. Something that has been more troublesome to us is, and you know this, we talked about this before earlier today, is that the other day or the other week I tried to upgrade the dependencies from Kubernetes. We used to be based on 1.11 to 1.14, and I found that there's quite a lack of documentation and how do you do this actually, because quite a bit changed, and it took me I think at least a week or two to figure out how to work it out, and I ran into a couple of issues that are mostly related to the extraction migration being in progress right now. Like if you're trying to run an out-of-tree cloud provider right now, at least the way I try to do it, it fails because there's some specific GCP flag that's been enabled by default. So your out-of-cloud provider installation thinks you're GCP and it's not working, and you need to make you basically need to work around that. So I admit that could be due to me doing it wrong, or maybe missing how this is working. But for somebody that is not as tightly integrated into the work that this SIG does right now, it took me quite some effort to figure out how to do this right.
So there's a lot of code that's in motion right now because of this extraction process. And for those of you who haven't been involved in it, what's happening is there's all of this code that is inside of Kubernetes that is being used by the in-tree cloud providers, and all of that code is being moved to staging. Staging in the Kubernetes repository is a place where we say that these are stable APIs that will not change, so that external providers, which we're trying to move all these in-tree providers out, they can begin to depend upon those and have that be reliable. But during that process, there's going to be a lot of shift and a lot of things breaking. And so when you run into issues where something like there's a GCP flag that is set implicitly and you don't know how to do it, it's great to be able to come to our meetings and tell us about it, and also file issues about it so that we can fix that, because that's not the experience we want to have for the end users. And this is kind of the ideal time to do it while we are moving these APIs over and getting ready to bake them in and stabilize them, before it becomes harder to say that, well, we're taking these stable APIs and now we might have to change them.
And one of the interesting things is that because the out-of-tree providers aren't deployed with Kubernetes, there's usually like a delay in terms of providers adopting the Cloud Controller Manager, like the new code in the Cloud Controller Manager, because they'll usually vendor it in a little bit after the release. And so we may not always catch those things. But like, it's a good point. Like, we should be testing a lot of those things as well. And maybe like component config and all those new features we want to add to Cloud Controller Manager could help with that. And
maybe just slightly related to that is, if I, like now with the dependencies updated, if I do like my binary -- help, I think there's a list, like a 3-page long list of flags that are now part of it, which probably, I guess it's related to the same point. Many of those should probably not be on that binary, but they are right now. So that is, it's not an issue per se, but it just makes it harder to understand, what kind of flags do you have and which are actually useful, necessary, helpful.
Yeah, and that's an artifact of, there was in order to help kickstart this process of creating out-of-tree providers, there's scaffolding code that's provided to you through the Cloud Controller Manager, so you can take the scaffolding code and run it, and just like you implement an interface and everything works. But then that means that you have, I think it's basically all of the options that come with
It got backported from the Kube Controller Manager. That's what happened. And so I definitely agree. Like, we should layer the component flags in a way where it's like these are the base component flags that all providers are going to need, and then you can dump your custom flags in a separate file and something like that, rather than just like importing everything and making you have to read through hundreds of lines of code for that.
Right.
So with the providers who are in tree, we've been looking at, what we've been talking about is trying to complete this extraction process by the end of the year, and that's just not the code coming out of Kubernetes, but also having some sort of migration path to, especially for people who have production clouds, to be able to migrate from their in-tree provider to their out-of-tree provider. And does anyone here have a sense of how that process is going, and do you still feel good about the path we're taking to move the code out and transition to external providers?
Hi, I'm Craig Peters. I work at Microsoft on Azure, and we've been working for quite a while. I just joined, so I'm catching up with what's been going on. We've been working quite a while to get the code out of tree, and we're at the point where we have functioning stuff. We can actually use AKS Engine, our tooling that creates Azure Resource Manager templates to test it. And the biggest thing we see right now for people is that they don't know how to do it. It's not well documented and it isn't clear. I think from a sort of structural and operational perspective, while it's a lot of labor, it's working well that way.
No, that's great, thank you.
So sorry, so to clarify, did you mean that from the perspective of users that are like deploying, like building their own clusters on Azure? Okay. But from an AKS point of view though, like from a managed offering point of view, it's fine? Okay. Okay, cool.
Yeah, and that illustrates one of the major modalities that we have, is that we have cloud providers who are offering managed Kubernetes, and they're using the cloud providers to provide clusters for their users. So the responsibility of kind of figuring out how to run those external, how to start that external provider code, which is, it's a separate binary that you start up and it communicates with the Kube API server, versus a user who has to show up and use kubeadmin to create a cluster, and how do you add on those additional external providers? A tip on that is, if you look at the kubeup script, they actually have some code in there which handles this, and you can get a sense of the things that you need to do to be able to start up an external provider when you're bringing a cluster up. And so that's not a replacement for documentation, but if you are kind of stuck on that right now, that's the place to start, and we can take that as one of our issues, is to make that easier for everybody else.
The other thing that has come up in discussions that we've had is the notion that as we release multiple versions of the Azure Cloud Provider, how do we think as a group about versioning, version compatibility, version matrices, those kinds of things? Is it something that each cloud provider should sort of do that on their own, or is it something that we should do together as a group, at least have some standards so that when users who are using multiple clouds can come in, they can understand the semantics of that?
Yeah, I think that's great. And actually, if I can put a pause on the conversation right now and maybe ask if someone would be willing to take some notes down on this, so that we would be able to record it and bring it into the discussion in general. Okay. Great.
Yeah, that's a good point. We can always loop back to the recording and jot some notes down.
Yeah, this is kind of an underlying topic of conversation across multiple SIGs. As Kubernetes, the repository gets broken into more and smaller repositories, and they have independent release cycles for those things. What does the release of Kubernetes look like in the dependency management? And this gets, we don't have no problems, we just have different problems. Core DNS replacing Kube DNS is one example. There are others. Ingress gets released independently. There are all kinds of things you need in addition to what is spit out of the Kubernetes release cycle. And we don't have a canonical answer for that today, but it is something that I think we, as a community, need to figure out what is the versioning. I think the simple answer is every minor release of Kubernetes has matching releases of the components that it must have with it. And that's not a perfect answer. It doesn't get the release velocity that those things necessarily need. But as a cloud provider, in this specific context, it does remove my need to wait for the Kubernetes patch release to fix some bug that's specific to GCP. And that is one of the primary benefits of this whole process is we discover a bug that affects only GCP users. We submit that patch to upstream Kubernetes because the cloud provider exists in tree there. And then we wait for a critical mass of changes to inspire someone who's the patch release manager to cut a new patch release of Kubernetes. And then we can release that to our users. And other cloud providers, if you actually look at the patch release history, it's typically, the majority of them are actually, AWS fixed this issue for AWS users, or Microsoft or Google or someone fixed a release that really only impacts their own code base. So my observation is that at least shortly after a new minor release of Kubernetes, there are a bunch of regressions that are fixed for individual providers. And so in addition to giving us better velocity over our own customer experience, I think it will reduce the amount of code going into Kubernetes itself after each minor patch release. Because we don't just fix things, we also introduce new bugs when we fix things. So this is the runaway train that we're trying to stop in general. Yeah. We have a
Okay, my name is Ricardo from CERN. I have a related question. So in addition to the release, if we would do patches on the out-of-tree provider, which versions of Kubernetes is it being tested against and validated? Like, would it be always the master, or how many releases it goes back and things like this?
So that's a really good question. One of the things we did in the cloud provider extraction project was we worked with some folks from SIG testing on extension of the test grid. And so external cloud providers can run their own end-to-end tests of the conformance tests and post results back to test grid. So we can see, for example, OpenStack or DigitalOcean or whatever cloud provider runs the integration in their own environment. They set up the cluster however they set up the cluster. They run the conformance test and then submit the results of the conformance test back to test grid, including what version is that running against. So we, as Google, can run 112, 113, 114 test results, and if only 114 turns red, then that means one thing. If all the providers turn red, it means we borked not only ourselves but someone else. And if we just borked one test, then it's a horizontal line, and now we know what to look at. But that's kind of does that answer the question?
Yep. Yeah, and every provider is responsible for providing their own test infrastructure, their own testing environment. Yeah, to be able to report back to the test grid. Test grid is available to everybody. You write into a bucket and it publishes those results. As far as how you manage versioning, especially right now with the changes that are happening in Kubernetes for the provider extraction, you should count on a new version of your cloud provider for every new version of Kubernetes and to sync those up. I don't think that it's going to be possible at this point in time to essentially have a versionless cloud provider that won't be guaranteed to not break against older versions of Kubernetes.
So maybe like some sort of consistent standard that we can try to design together across all the providers might be a good action item for when we go back.
And it's like way more complicated than cloud providers because there's also CSI drivers that go with certain versions. There's, again, the core DNS examples. There's etcd, there's FluentD. There's what we do is kind of insane on some level. So we do need some consistency across that.
I have a question about this architecture with the provider code outside of the main tree. Did anyone think about the concern of having a provider blocked with compatibility at a certain Kubernetes version, so that you cannot anymore upgrade because the provider you're using is not supporting newer versions of Kubernetes? I know that maybe this is not the case today, but looking at the experience with other open source projects in the past, like OpenStack, I don't want to be in 4 years from now using a cloud provider that supports up to Kubernetes, I don't know, 1.16, and then Kubernetes is now at 1.20 something, and I cannot upgrade because the provider is kind of frozen. I mean, I just wanted to start this conversation because it's better to start
there is a conformance program, and part of the conformance program, if you pass the conformance tests, is what gives you the right to use the word Kubernetes in your offering. And there is a duration for which that lasts. It's like 12 months, I think. But I would encourage you to go look at the conformance program guidelines. And you can certify against, say, 114. You can still publish that it's something Kubernetes, whatever service or engine or project for 12 months. And then if you haven't certified a version in the meantime, then your certification expires and you have to take down the word Kubernetes. On what version of the cloud provider code exists with a Kubernetes project, we will never stop the Kubernetes project progress because a provider doesn't continue to update their cloud provider. But that cloud provider is also the one provisioning the clusters at whatever version still works with their cloud provider. So I would expect they just won't offer the next version of Kubernetes, and that because the portability of applications, you would be free to choose another provider.
And it'll be the responsibility of the user group that owns that code to develop that. And so if that code stops being developed, it's because there's not enough interest from their user community or from their developer community to maintain that. But this is also part of the reason why it's important that this this extraction happens, because right now we have cloud providers in tree that aren't maintained, and we don't know if they have users. And this is code that is just sitting there, and it becomes a burden upon the larger community. And so, you should think about it as an opportunity for the experts who are working on these particular drivers and who are working on these providers to be able to give you the best user experience. And if you don't feel like you're getting that experience and it's not being updated, then engaging with that user group or that SIG right now is the best way to prevent that from happening.
Yeah, and one of the nicest things about being out of tree is that if cloud provider ABC doesn't stop supporting or stop maintaining their provider, like you can write your own, and it could become the canonical provider for that cloud provider, and you don't have to work for them to write it. And the community can say like, oh, this is the most well-maintained, we're going to use it. And so like, same thing with Intri, like we're, on the next release, we're going to delete, I think like Photon, Overt, and CloudStack because we couldn't find anyone to maintain it. And so in the end, we're just going to be like, we're just going to delete it because no one's maintaining it. So
double points for deleting lines of code. Double points for everyone. So we're 20 minutes in. Do we want to go on to a next topic, or do we have more? All right.
So if you just go to the next slide, I've reorganized.
Next slide, maybe.
Maybe. Yeah, you may have to reload the slides.
Oh goodness. There we go.
Was it?
Don't go to governance.
Yeah,
Nobody
so
raised a hand for governance. So
enhancements were next, and then we'll follow that up with code organization. So on the enhancements, do we remember the particular topic on enhancements that we wanted to talk about?
So maybe a second vote for which enhancements to, or I guess like maybe fielding like this. Is there any particular features that people wanted from the cloud provider that doesn't exist today?
So there is one thing, as an end user developer, I would like cloud provider maybe have some metadata fields from, like require some metadata fields from the, let's say load balancers and volumes, like let's say, storage classes. Let's say if my cloud provider provides a storage class, it has, let's say, it's like file-based, let's say, or block-based. If it's let's say, so that I can decide, can I deploy MySQL with it or not? And for load balancer, let's say it will like, if it's public or private, something like this, some metadata field, so I can see it as developer in the end.
So you kind of want the cloud provider to describe its capabilities?
Yes, like have this metadata fields as capabilities, and like when I can see some metadata on the nodes, I can see some metadata on the storage classes or metadata on the load balancer that I can then like check what's happening.
Anybody else want to build on that? Go a different direction?
So we definitely have that problem right now with pretty much everything where so load balancers is a great example, right? Because every cloud provider implements load balancers differently. And so like if you want a very AWS specific thing, the natural thing that we've done is stick it in an annotation and throw it on the service resource. But what you end up with is you have like not 100, but like you have lots of annotations representing just the load balancer implementation of one provider. So we need like better abstractions to pull in like the capabilities into. So like one topic that's come up before is like, should load balancers be its own resource, or at least a SIG-Cloud-Provider endorsed CRD that can kind of handle that information better. So yeah, that's definitely an enhancement that we could probably look into.
Yeah, these are super hard because they often become the least common denominator, and then you're not getting as much value out of any implementation. So these conversations tend to be fairly long. So I love digging into it more, but we should go into it with clear expectations. In SIG apps, they have an application CRD that's been swirling around for a year at this point and maybe making progress now, but it's taken some time to get alignment there. But I agree with the sentiment that never-ending annotations is not the right thing, and then eventually we promote it to a field, and then everything breaks. So I'm a fan of the direction. Others? Enhancements, things we ought to be thinking about that we're not. What are you wasting your time for on this stuff? You should be thinking about this other thing. Any of it?
Y'all raised your hand for this topic, so someone has to have more.
Hi, Alex, my name. I'm working on integrating Kubernetes on our OpenStack platform internally. And it's more of a general question. So if there's some decision being made on an enhancement which should be present in all cloud providers, is there some sort of process or like some way it's ensured that it's actually going to be implemented in the next release? Or yeah, I mean, that we don't run into a situation where one cloud provider implements all the cool features and the other one's lagging behind because of resources and so on.
Yeah, that's definitely a concern, and one of the big reasons why we're pushing the whole extraction migration thing, because the way the current providers are implemented was exactly in an organic way, where like like the early cloud providers was like Google and Amazon, and so we built the interface on top of what worked on Google and Amazon. And then, so when you have like OpenStack or other providers that may come in after, you realize like, oh, not everyone has the zones and regions, and not everyone has load balancers in the same way. And so we're like undoing a lot of that. And so the big reason why we're pushing for the whole like all the cloud providers in a single SIG is so that we can vote in a SIG and say like, make sure that the right technical leads from the right cloud providers are there to say that this feature actually won't work for our users because we don't implement zones or we don't implement whatever.
Yeah, and one of the great things that's happened in this cycle, and I want to say thanks to Andrew for putting in a ton of work to get this up and running, is helping to set up priorities for the issues that we have so that during this cycle, we know the things that we should be working on, that we should be focusing our energies on. And so, the place to start on, if you're an individual cloud provider and you think that you have something that is more widely applicable and that everyone would benefit if it were done in a standardized way or had some sort of standard API, is to file an issue and also come to the meetings and bring that up and advocate for it, because that is, that's largely how things get accomplished. And so this is actually the venue for that to happen, and we're we're a young enough SIG still, but we have enough reach that you can have some really a deep and positive impact in the community if you share these broadly. And our meetings are weekly on a Wednesday.
Wednesday, 4 p.m. Eastern, 1 p.m. Yep. But to that point though, like because we know that it's not just Google anymore that's running Kubernetes, and there's hundreds of providers probably that want to do it, we really have to be more mindful of like features or new integrations, and we have to make sure that there's a reasonable critical mass of providers that want a feature before we go ahead and add it. Because the more things we throw at it, it becomes a mess and hard to maintain.
And there aren't great reasons for the way some things are. Like it just was the way somebody did it on a Tuesday afternoon, and because everyone's perspective is the only one they have, it would work for them, and that's the way it is. But you may find that you have a proposal and there's no objection whatsoever, and everybody cruises along with it. It can be surprising that way. So.
Yeah.
Others. So we got big themes, right? There's like consistency across providers and discoverability of behaviors or capabilities of those providers. Were kind of a couple of the big themes that I heard there.
Yeah, so I think the provider-specific topology labels has been a pretty hot topic lately. And so right now, when you register a node, it'll query the provider and it'll put a zone and region label, and you use the zone label to do like volume-aware topology and all that stuff. But there's been recent discussions around like should there be more labels like physical host or like the hypervisor or like a rack label, so that you can split your topology into smaller chunks and allow for smaller failure domains. And so, do people have thoughts on, what if there should be more topology labels in zones and regions, and if so, like what's the use case? What provider would need that, and so forth? Anyone have thoughts on that?
Like rack, machine, physical host.
Do we feel that it's like enough to justify a codified label?
I don't know. I'm just planting suggestions that came from the community in the last month.
Yeah, physical machine and rack were the two big.
No strong feelings, it looks like. Yeah. Race condition.
So one of the things that a bunch of us have been working on are things like virtual nodes. And so an annotation, some way to indicate to the scheduler that something might not be an actual physical node or might have some different other kind of characteristics is likely to be useful. I think this is very related to the same concept here, but it actually relates specifically to node, not some new idea.
So is that a capability of the provider or a capability of the node? Like, is that taint and toleration sufficient for what workload will run?
Yeah, taints and tolerations do it at the workload level, but they don't necessarily provide the right information for the scheduler.
Okay. I know this is a deep and I have not been involved in that conversation, so I won't comment on it, but okay.
That's as deep as I can go anyway.
Okay.
Today.
So I know that personally out of this list on the possible enhancements, rate limiting is something that's come up repeatedly in the OpenStack community and from other communities where the providers in general, Kubernetes its event loop can be very chatty against the API, and some people are running into problems where they go to their vendor and run on their cloud, and then all of a sudden their cluster stops working because they're rate limited on the APIs. And it's my understanding that it's pretty deeply embedded into the Kubernetes control loop,
I know there's a lot of work going on in specifically this area in SIG API machinery. Is there anyone from API machinery here? I can't remember the PR number. Brian Grant would be able to tell you the pull request number. I can't, but.
Hi, I'm Christian. I'm from Daimler. We're building on OpenStack. I'm not from SIG API machinery, but I can say something to that. We are deploying lots of Kubernetes clusters, and we're not getting kind of rate limiting problems, but we're kind of DDoSing our IS
same.
stack. So
Related.
But the out of tree cloud provider, we see huge improvements in less requests.
That's good. Yeah. DDoS is a natural rate limiting.
No, but there are lots of efforts underway in related areas. So there's like a watch cache project to not have to read back from the beginning of time if you reconnect to the API server. That should help on some of this. There's also changes in the node heartbeats behavior so that with lots of nodes you don't overwhelm your API server. And then specifically in this rate limiting and fairness, and this is a very deep topic where many of us have been through this in other projects in the past. It's not a new idea. It's just now where with as many clients of the API server as there can be, it becomes an issue. So one of the things that's interesting about Kubernetes is it's not always the traffic from the external internet, it's the traffic between the things that enable all of this self-healing and reaction to changes in desired state, for example. But it can pile up, especially in really large clusters. So what works really well in 3-node clusters does not work well in 5,000 node clusters, sadly.
Yeah, so I'd actually like to get a sense of how big of a problem like running out of API quotas is for Kubernetes. So like raise your hand if you've deployed a cluster somewhere and then some functionality broke because you ran out of API quotas. Okay, so I guess like mostly large clusters.
There's also a resource quota in Kubernetes and sometimes requires some plumbing through the individual provider. Are folks using resource quotas also? Kind of acts as a guardrail at the edge so you don't explode your cluster. We have customers who try to make 700,000 namespaces and then they're confused why something went wrong. So it helps in that use case.
Hi, I'm Chris from Envoy. We have and we run OpenStack as well, and we have the problem in the opposite direction. Like when, let's say, you have a couple of members in a load balancer, you DDoS your LBAS implementation on the cloud provider side, and it doesn't keep up, and Kubernetes continues to try again and try again and try again, and nothing will happen.
Yeah, no back off logic and.
Yeah, and things stuck in unable to do anything here.
This is also, there will be a SIG OpenStack talk tomorrow also, so that we can work through some of these issues individually also. But yeah, it sounds like something for us to maybe take a look into and see what the root cause is and propose some solutions on that.
Yeah, I like the resource quota suggestion. Maybe we can have some sort of integration with resource quota definition to pull how many API requests we're making to cloud APIs and do something with that maybe. Yeah. Two.
Oh, and one there.
Hey, my name is Ishwar. I manage Amazon EKS. So this is a near and dear topic for us, actually. A lot of our customers end up being rate limited at large scale, right? So, I mean, this is a topic that even we're talking with Mike here is our active participant in the cloud provider group. So even though there have been a number of improvements in the AWS part of the cloud provider, like things where API calls that need not be happening were happening, duplicate calls that we don't need to do. Number two, batching wasn't implemented, so that was added a little later, right? We still run into throttling issues, right? So like now we are discussing on how maybe we could potentially have a cache. So the entire problem being like you have a number of entities not coordinated, distributed, right? Because nodes are also utilizing the API calls at the end of the day, right? Doing their own API calls, and as the cluster scales, you have more number of API calls leading to throttles, right? And you're in a downward spiral, right? You back off, retry, right? So we've been thinking about potentially having a cache that serves as an intermediary, right? So that you don't need to do API calls repeatedly at the end of the day, right? Obviously, with cache comes problems with cache inconsistency and stuff like that, right? So if more cloud providers are ending up in that state, maybe the SIG cloud provider can think of thinking of a cache framework or a library, right, that provides this kind of feature.
Yeah, I think there are some investments in that. Something node local cache is something I know the node team is looking into as well. As you point out, then everything becomes a cache and validation problem, and consistency is important. But again, it's kind of the benefit of the system as a whole is this very decoupled behavior of all of these independently evolving components, and that comes with a cost in the chattiness and connection. So what did we call it? Chunking of lists is one thing that we added in API machinery recently, so you don't have to get a whole list of things. Most of these are about behavior in very large clusters. So the concepts that work really well with small clusters, you need to rethink when there are large clusters. Yeah. And those conversations get very long and detailed, and very smart people who have done this before are thinking about many of those things. I would very much like to avoid building another cache solution that is not an academic exercise anymore. We really shouldn't solve the same problem multiple times, but I hear what you're saying. It's a good pattern to clarify.
Yes, I know Azure, they had a problem with the route controller, and because they would do like a list routes on every single route on the table. And so they implemented their own cache behind the interface, and that worked out. So yeah, like for EKS or for Amazon customers, maybe a more practical approach is like implement caching and then bring it back to the SIG. Like, let's look at it together. Maybe this is something that all the providers should do as a catch-all, or maybe your solution solved a very specific case for Amazon, and so yeah. So let's follow up and make sure that.
But also check in with SIG Scalability. They've been looking at a lot of these from the scalability perspective, and specifically about large clusters. So there's a lot of improvements on services and number of endpoints per service, and how to have endpoints and shard endpoints across endpoint slices or something. I can't remember the name. Endpoint slice, yeah. So there's a lot of effort in that direction from that perspective. And it would be great to get your input on what are some other scalability challenges and where to focus that energy.
Just a question about the version numbering of all this stuff. So we will end up in a situation where we have a Kubernetes version, and we will have a cloud provider version, and eventually also the kubectl client version to track. So in the case of Kubernetes operators, they have to channel feedback on issues and problems they have. I'm not sure, do we give the possibility with a command to retrieve all the versions of these components that are moving? Because if I understand correctly, for a network plugin, it's something that you can deploy at a later stage with kubectl itself, so you have kind of more control over it. But the provider, the external provider, is kind of injected in the kubelet command line arguments, so you don't necessarily have visibility on the version you are running. For example, if I run a managed Kubernetes on GKE, do I have visibility on the version of the external provider out of 3 that is running or not? Actually, I don't know. So is this important or not?
There's a long and complicated answer to that. Yes, you get a version of GKE that includes the Kubernetes OSS Kubernetes version in it for convenience, but it also, as you point out, contains a lot of other components. I think discoverability of what version of all of those components is really useful, so that you can go to Stack Overflow and see, did someone have a problem with this version of etcd and that version of Fluentd? And I need to know that, right? I need to be able to discover it. My hope is that over time, as all of the APIs that a user needs to run Kubernetes are GA and have backwards compatibility, users will have less focus on the version of Kubernetes that they're running and more over the behaviors that are exposed by the API. I think APIs have versions. The binaries that back them ought not to have versions that users care about until something goes wrong. That's
yeah, but it's still having a standard way to be able to query what
yeah,
versions
like
of things are
it
running.
should be
like,
self-describing, but not important.
Yeah, it should, yeah. But this is it mirrors other things I've heard where you know, like, you know, people also want other information. It's helpful in tracing. It's helpful in you know, for operators. Users should care less, but there may be a way to provide that in a consistent way, maybe through some sort of API.
And I think the cluster bundle project is one that might be worth looking into, and I think it intends to describe the combination of versioned components that are together in this distribution of Kubernetes that I, the user, am interacting with. I don't know what level of maturity that is, but I think that's on the right track conceptually.
But as far as I know, the only thing that the external provider said is a name. So it says, my name is this provider, and I think, you know, version might be included in that name, but I don't think there's anything explicit in the API that sets that for you.
It's a good idea, though, to make sure we include that. So troubleshooting. I know our support people will get mad at me if there's no way to tell, so thanks. You have support people that get mad at you too, I take it? Sometimes. Other folks? Yeah. Okay.
Next topic.
We probably have time for one more. Where are we going here?
So the next topic is
this one?
Code organization for cloud provider subprojects. A lot of people raised their hands on this one also. So this one also, this is something that has come partly out of OpenStack, where OpenStack has a mono repository. So you just go to cloud provider OpenStack and you wind up with everything, almost everything OpenStack does, all the storage, all of the auth, all of the provider itself. And we want to break that up, and we would like to break that up in a way so that when someone wants to go and find, like, we are looking for the ingress controller for this, that we have the name that matches everyone else's ingress controller. So if you're, you know, you want the Google ingress controller, you know, it's just, you know, like a prefix or a postfix is the same, and, you know, and we can all find that in the same place. So I think that's part of where our community was coming at it from, but I don't know if anyone else has run into similar issues or how they're organizing their code and how they would like to see code organized within the Kubernetes organization.
Put differently, we kind of have an exodus from the Kubernetes repository, but no real plan for where anyone is going, so it's being discovered in motion, and it would be nice to have a roadmap for where we might go, so it's well thought through. Another thing that's really hard is if people work across multiple projects, this idea of vendoring in and what version of what repository do you, it's like, can get very complicated. Yeah.
We can have a separate organization like CSI have, Kubernetes CSI or Kubernetes 6. We can have a Kubernetes Cloud-Provider organization. Yeah.
Thank you, and that was Aditi from NEC. We do have Kubernetes SIGs, cloud provider, and code in there now. I think the question is about other parts of the organization, and if we want to collect all the things that you want for a given distribution on a cloud provider in that one place, or have consistency about where they point to elsewhere. And I think where it gets really confusing is there are like CSI driver implementations that are intended to work across clouds. So it isn't the case that it belongs to only one subtree. And I'm not an expert on remote repos and how to point to another repo, but I know it is not straightforward in many cases. So I don't have the right answer here or any real position. I just know it's tricky. Is anyone interested in trying to come up with a proposal or try and think about all the things that are required and are currently moving out of tree and what to do about them?
Yes. I mean, we're interested in it, you know, the SIG OpenStack group. And that was something that we wanted to bring to the community before.
I was trying to find help
I know,
for you, Chris, not you, Chris.
But But is there anyone who is also interested in this? Because that's, yeah, we would like to have help on that.
And SIG Architecture also has a code organization, so project that's also trying to focus on this kind of work. And the cloud provider SIG is definitely like one of the key stakeholders because we're having this huge sprawl of repositories that we have to maintain. And
yeah, homework, go implement a feature where you have to update 3 of those different repositories and figure out which to commit first.
Which to vendor and which yeah.
And I actually think the original KEP that proposed this SIG, set everything up as like a mono repository.
It's very easy and
yeah, it's an easy place to start and a hard thing to undo.
My personal take is actually to have a monorepo per provider, and then just kind of organize the monorepo in a nice way. That way you can, if you need to make a CSI change that depends on a cloud provider implementation, you can bundle it together and whatever.
So the problem that we have faced with that is versioning. And so when we do an update to our ingress controller, and it's a bug fix, we have to re-release everything to have this one thing released and updated. And so it's actually, it's turned into a nightmare for us.
Staging monorepo?
Yeah.
I don't know. Maybe that's a bad idea.
Anybody else on this topic? Some people raised hands. Do people have thoughts or just wanted to spark some conversation? I'm a trained facilitator. I can stay quiet longer than you can.
Should we just open it up for other random?
Yeah, sure.
How are we doing on time?
So yeah, if anyone, I think we have about 20 minutes left. If anyone has just any random things they want to bring up in terms of cloud provider integrations, yeah.
Is this on? Yes, it is. So this is a beginner's question. I'm new to these SIGs and I'm trying to navigate them. It's not an easy thing. How does this SIG relate to the service catalog SIG? So for me, the cloud providers provide services, and now there are 2 different SIGs. How do you relate to that one?
I'll take a swing at it. So the service catalog intends to expose managed services to workloads running in your Kubernetes cluster in a consistent way, is my understanding, interpretation. I haven't worked on it, so if you use managed database, you say provision make a new instance of that managed database and give me an endpoint for Redis or whatever. And then it returns that endpoint, and your services running in your cluster can access that as if it were local to the cluster, even though it's far away. This SIG does not give any guidance on how service catalog should behave or work directly with the managed services in the cloud providers. It's more earlier in time than that. The cluster had to exist, and creating that cluster requires some integration with persistent disks and load balancers and infrastructure provided by the infrastructure provider. And what we try to do is make that work in a consistent way. And then once the cluster is running, Service Catalog provides access to external services that are also running and started before then. So that's how I would characterize it. Others want to take a swing at it?
I think we implement in the cloud providers the core primitives of Kubernetes that have to be implemented specifically to the cloud provider as load balancers, as storage, such things, and not the specific services the cloud provider offers as well, like Redis and so on. It's just the core components that we implement in the specific cloud providers.
But I agree though, like it's hard to navigate SIG sometimes because there's so much cross-cutting work sometimes, and it's hard to navigate. So I understand.
I have a similar question for the cluster autoscaler. So right now the cloud provider code is inside the autoscaler repo. Would that move out to the specific cloud providers, and which SIG would be managing this?
Yeah, so you're talking about like the provider implementations in the cluster autoscaler, right? Yeah, so that's an interesting case because it's cluster autoscaler is an add-on, so like they can choose to do that implementation their own way. And I think I've talked to, I forgot his name, but one of the chairs of SIG autoscaling, and the approach that they took instead was to use build tags. So they bundle all the providers in the same repository, and they have a default build tag that compiles all the providers into it, but then they have specific build tags so you can build a specific version of it yourself that only imports the provider you want. But yeah, there's no plans right now to do an out-of-tree version of that or anything like that.
Yeah. Hello, I'm Joshua from the Swiss Broadcasting Corporation. We are using CloudStack, and you said it is now removed.
Next version, 1.16.
Next version.
That's the plan, at least.
Okay, I already knew it is going to be removed, and we took the code out of it and extended it a bit because it had some problems and it didn't even work in tree. And now I want to ask how can I get it back into the Kubernetes project and in the organization.
Sorry, so to clarify, so you said you took the in-tree version and you brought it out of tree in your own, like you took it out of tree, you extended a little bit, added new features.
Our organization,
okay,
we extended it.
Okay, and so now you want to like backport it back into the Kubernetes organization. And so we have a few requirements for Kubernetes-sponsored repository, which are like you need like real users using your provider. You need like a stable, like some sort of like beta version of a cloud controller manager, which you seem to have. You need docs. You need to report test results, test grid. So we have a CAP proposal. So you'd have to create a CAP that says like this is a provider I want to support in the Kubernetes repository or the organization. And if you fill that out, we can approve it, and then we'll give you a repository to put the cloud stack provider in there. Yeah, but yeah, reach out on Slack, and I can give you more details on how to do that. Yeah. But it's good to know that the cloud stack provider is being used, though. I didn't know that.
Others? Anyone? Questions, comments, snide remarks? Anybody? All right, well, maybe we wrap it up a few minutes early.
Yeah, sounds good. All right, thanks, everyone.
Thanks for taking the time. Really appreciate it.
Thanks, everyone.
Take care.